students, today I am going to start the chemistry subject of class 8th, chapter 1st, matter. You know that matter is made up of tiny particles called molecules. So, what is matter? Matter is something that occupies space and has its own mass, that is called matter. You know that matter is made up of the tiny particles called molecules. So what is matter made of? Matter is made up of tiny particles which is known as molecules. And that molecules are held together by a force of attraction called intermolecular force. So what is intermolecular force? Molecules in which they are held together by a force of attraction is called intermolecular force. There is also space between the particles called intermolecular space. That it means that the space in each of the particles is called the intermolecular space. And here is the diagram of the intermolecular space and intermolecular force. Next, the force of attraction and also the space between the particles, that is molecules, differ from substance to substance. It means that the force of attraction and the space of each of the particles, such as molecules, differ from substance to substance. But for any other substance, when there is an intermolecular force is stronger, then intermolecular space will automatically smaller, and when there is an intermolecular force weaker, and then automatically intermolecular space will larger. And here we know about the states of matter that you have studied in earlier class. And there are three states of matter: solid, liquid and gaseous. For example, water also exists in three states. In what are the three states? That are ice that consists in solid state, and water that consists in liquid state, and water vapor that consists in gaseous state. And here we must understand that the kind of matter, that is the molecules of consisting of ice, water or water vapor, is the same that water H2O. And now we study about what are the causes of the differences between in states. For any substance, the molecules making up the substance do not change in the three states. Here we ask that the molecules that are made by substance that consist in three states, they don't change. Then why is it that the substance exists in three states? So why each of the substance consists in different states? Its answer is, it is in fact the force and the space between the molecules that determine the state of matter. The answer is that the force and the space between each of the particles, each of the molecules, that are determining the state of matter, that what state of matter they exist. So now the intermolecular force is strongest in the solid state, weaker in the liquid state, and the weakest in the gaseous state. So in the gaseous state, the intermolecular force is weakest, and in liquid state the intermolecular force is weaker, and the intermolecular force in solid state is strongest. So like this diagram, that the solid particles are tightly packed between no any gaps or spaces. So the intermolecular force is smallest in solid state, and intermolecular space is smallest in solid state, larger in liquid state, and largest in gaseous state. Now here we can see that in solid they are tightly packed and the intermolecular spaces are much less, and in liquid there are larger intermolecular space, that there are in particles there are many spaces, there are vast number of spaces in each of the particles. And in gas, a balloon is inflated, and in balloon a gas is that have much large capacity of gas in each of the molecules. Then Thus, the molecules are most tightly held in solids, loosely held in liquids, and almost independent of each other in gases. And what is known that the molecules in solids are tightly packed, as I told recently, and in liquids they are loosely held, and in gases they are almost independent. That independent means they can move from here to there independently, and that they are not tightly packed. This explains the general behavior of solid, liquid, and gases. So the following paragraphs explain that the solids, liquids, and gases general behavior. That what type of general behavior they have. Now, interconversion of states of matter. Now we are going to know about the interconversion of states of matter. As you know, on heating, ice turns into water and water into steam, and on cooling, steam turns into water and water into ice. Here they tell that as we know that on heating, when we burn the ice, when we melt ice, that it changes into water, and when we burn water, it changes into steam, that is known as evaporation. And our second point is that on cooling, when we cool steam, then steam turned into water, and when we cool water, the water changed into ice. Such a change in state may be brought about in other substances too, without a change in composition. So, without changing in the composition, the change in state can be brought about in other substances also. So here is a diagram flow chart that explains that when a solid is heated, it becomes liquid, and when a liquid is heated, it becomes gas. And when gas is cooled, it becomes liquid state, and when liquid is cooled, it becomes solid state. This type of method is called the interconversion of states of matter that we read about. The constant temperature at which a solid turns into the corresponding liquid is called melting point of the solid. So here we know that what is the melting point of the solid? That is the same temperature at which a solid turns into the liquid, that is called the melting point of the solid. And the same temperature in which liquid freezes, in which liquid cools, that changes into solid is called freezing point of the liquid. And ordinarily the freezing point of the liquid is same as the melting point of the corresponding solid. And for example, when water freezes and when ice melts, that both conditions include temperature of 0 degrees Celsius. And also the same temperature at which the liquid boils is called the boiling point of the liquid. For example, the boiling point of water needs the temperature, what temperature? 100 degrees Celsius. And it is the temperature at which steam will condense. And 100 degrees Celsius is also the temperature in which condensation occurs in steam. So thanks guys, and this is the part 1 of the chemistry first chapter matter. And if you want to listen further parts also, so please subscribe and like my video, my channel, that you can listen other further parts also, that I will explain part 2 and part 3 of this chapter also. Thank you guys.